Hey guys, welcome back to AlgoYogi. We are doing two pointers series, and our next problem in the list is sort array by parity. Let's go to the problem on LeetCode. It's a easy description. So given an integer array nums, move all the even integers at the end of the array followed by all the odd integers. So we are given an array which has like all sorts of numbers. Now we need to place all the even integers right in the front and all odd integers right in the back. So in the first example, you can see it's like 3, 1, 2, 4, and result is basically 2, 4. These are even and remaining are odd. So let's see how we are actually going to approach this problem. So you can see here the nums array, and now we need to basically return 2, 4, 1, and 3. So remember, actually this should be actually 3, 3, and 1. Let's just maintain the order, and I think if we do it right, we will maintain the order. Although they're saying like return any array that satisfies the condition, so it doesn't really matter. Any array, any permutation that satisfies this condition, that has all the even integers in the front and odd integers in the end of the array, then it's an accepted solution. So let's approach the problem. So it's a 2 pointer, so we're going to have 2 pointers, and let's have our pointers as start. So start of the array and end of the array as e. Now what we are going to do is we will have a while loop. We're going to start our iteration, and while loop will say if s is basically smaller than e, then we have some numbers to process, and if it is just one number remaining, that means it was supposed to be there, whatever it is. It could be either odd or even. It was we don't need to change anything about that number, because it will either be part of the even or odd. So if s is lesser than e, that means what? We will have to check if s is pointing to odd number. If it is, then let's send it back to basically our end. So if basically nums s is not a even integer, sorry, not an even integer, that's true. So if it is not equal to 0, so that means we will basically swap these values, end and start. We will swap these values. But remember, this particular value isn't guaranteed that it is even. All right, so it's not guaranteed that we are basically swapping an even value in the front. It could still be an odd value, right? So but what we really want to do, we at least want to send this one back. This will change the order, but what might happen, this will either come as like an even value. This will either be an even value or odd value. But once we move this one for sure that this was odd in the back, then we can just decrement our e pointers. Okay, so if this is the case, that means what? We will move our e pointer by 1. So we will basically decrement e by 1. All right, otherwise else we will increment our start. Let's just say it s. We will increment s by 1. Why this works? If this was odd, which is over here, that means we swap these values. So along with this, remember, we are swapping this value. So at this place, swap e with s. This is where we swap. After swapping, we decrement this. So what will happen is these 2, 3, and 4 will be swapped. Now it will be 4 and 3, and e will be basically moved. E will be moved over here because we are decrementing it, and then we will again check if s is less than e. Then we're gonna check this. This is condition. This is not gonna basically satisfy. So this will go to else case, and else case will increment to this one. So now s will point over here, and then we will check if this is odd, this is odd. So what we will do is swap these two, and in the end it will become this. So 2 and 1, that's it. Once we are done, we will check this condition. Actually now s will be pointing here, and e will be pointing basically, I think, again over here. But now they're equal, so then they can just, you know, quack. All right, so let's write the solution. I think it's a really easy, straightforward. Let's change our view here, and awesome. So as I said, we're gonna have 2 pointers. One is start, let's call it s, and e, pointing to 0, and length of the nums, and -1, just you know, so that it's pointing to the valid index and not the length, because it starts at 0. I'm going to start saying it you know, in the upcoming videos, because it's such a straightforward thing. Now let's have a while loop. While s is less than e, then if my nums at s is not even, we're checking it using the mode. If it is not even, which means it's odd, so swap the value. So nums s, you can do it using the temp variable, but I think this also works in Python. You know, you can do it in single line, just the same thing, but just swap it. It will itself use that temporary thing and update them with perfect value. So e takes s, and s takes e. Okay, and then decrement e by 1, else increment s by 1. That's the entire solution, and we need to return our updated nums. I think that's it. So let's zoom out and run it on our examples. Perfect. Let's submit it. Awesome. Okay, let's write the time complexity, which is big of n, because we are iterating the entire array just once, basically, although we're doing it from front and back, a lot of swapping and all, but still we just, you know, iterating it most at one. And then we're doing it in place, so space complexity is not going to be anything other than constant 1. Let's go to AlgoYogi and mark this problem solved, and see you guys in the next problem later. Until then, bye bye.